Hello everyone, welcome to my channel. Today we'll see some other examples from Chapter 5, Functional Group Transformation, the Chemistry of Carbon-Carbon pi bonds from Zweifel Nantz Book. Now let us start with this example. First of all, MgBr2 is given as a catalyst. So MgBr. In the first step, the lone pair on the oxygen atom is going to attack on the magnesium, and this one of the bromine is going to leave, and it will give us MgBr, and there will be generation of positive charge on the oxygen atom. And then since oxygen is an electronegative atom, so the positive charge is not stable right here, so this bond will break and this positive charge will neutralize, and it will give us and the positive charge will be then on the carbon atom. And then in the next step a rearrangement is going to take place. Okay, so this bond will break and this carbon will get attached to this carbon, and it will give us a 5-member tree: carbon, oxygen, MgBr, and in this time this carbon atom has a positive charge. And then in the next step, this positive charge is further stabilized, this bond will break, MgBr will leave, and there will be double bond. That is a hydrogen, right? So it is an aldehyde. Then reaction with pH, CH2, sorry, there is Mg is there, MgBr. Okay, this is Grignard reagent. So it is delta minus, and it is partially positive in charge, magnesium delta plus. So this negative charge is going to attack on the carbonyl carbon, and negative charge will be in the oxygen atom. Okay, this negative charge is further going to attack the magnesium, and thus it will give us hydrogen O, MgBr, and CH2 pH, right? Then in the next step, since NH4Cl is given, so this bond will further convert it into OH. Okay, it will abstract a proton and will give us our product as OH, just giving us an alcohol. Okay, so this is the final product of this reaction. Let us move on to our next question. So in this question, what are the products formed here? A, B, C. Okay, first of all, this is dimethyl sulfonium methylide. It is a sulfurylide. Okay, sulfurylide. This one is also a sulfurylide, and this one is CH2I2 in presence of zinc copper. This is what reaction? Simon's reaction. Simon-Smith reaction. Okay, Simon-Smith reaction. Now in the first one, there is it is stabilized because the negative charge on the carbon atom can go here and negative charge will be on the oxygen atom. So this one is stabilized. Whenever you see an sulfurylide which is stabilized, then it will give us in the formation of cyclopropane. Okay, and this one is there is no stabilization, okay, of this negative charge. So whenever a sulfurylide has no stabilization, then this one will give us a epoxide, and this one is Simon-Smith reaction. It is going to give us a cyclopropane. Now the question is, what will be the products of this reaction? In the first one, it is an stabilized sulfurylide. Okay, in case of stabilized sulfurylide, the attack will be on the alpha beta unsaturated compound. Okay, alpha beta unsaturated cyclopropane is going to be formed. You have to remember this one. Okay, whenever you see an stabilized sulfurylide, the product will be this one. So this is the product in A. Okay, now let's see what will be the product in B and C. In case of B, there is no stabilization of this negative charge. Okay, so in this case epoxide is going to formed, since only one carbon is there, so directly we can make it an epoxide. Okay, the rest of the thing will remain the same and there will be an epoxide. Okay, so this will be the product forming B. Now let's see what happens with Simon-Smith reaction. In case of this, whenever you see a more electron density means double bond, then cyclopropane is going to be formed there. Okay, now cyclopropane is going to be formed in this double bond. Why? Because it is it has more electron density, whereas it has less electron density, because this can undergo conjugation, so electron density will be less here, so cyclopropane is going to be formed here. Okay, so it will give us our product as it has less electron density due to conjugation, so this will be the final product of this reaction, and this will be C, A, B and C. Let us move on to our next question. So in this reaction, what is the product formed? First of all, diazomethane is given. Okay, so let me write diazomethane CH2, so there will be negative charge here, so this is diazomethane. Now the negative charge on this carbon atom is going to abstract a proton, the most acidic proton. So which is the most acidic proton, this one or this one? This is a carboxylic acid, this is an alcohol, so the hydrogen on this carboxylic acid is more acidic, right? So let me write it, C double bond O H, right? So in the next step, this negative charge is going to abstract this proton and there will be negative charge on the oxygen atom. Okay, and then the negative charge on the oxygen atom is going to attack on the carbon, nucleophilic attack, and N2 is going to leave. Okay, nitrogen gas is going to leave, thus giving us so this will be the product formed first here, then acetate anhydride is given, CH3 C double bond O C double bond O CH3 in presence of pyridine. Okay, first of all it is going to abstract this acidic proton and negative charge will be on the oxygen atom. Then this negative charge on the oxygen atom is going to attack on the carbon, it will go up, come back, and this bond will break, thus giving us OAC here. Okay, we got this product in the second step, and then in the third step osmium tetroxide is given. Osmium tetroxide is given, and this function is to convert this alkene into diol. Okay, so finally the product will be this one, convert this alkene into diol. So this will be the final product of this reaction. Now let us see this question. So what will be the product formed here on reaction with CSA? CSA is camphor sulfonic acid. Okay, camphor sulfonic acid stands for CSA. So finally what is the role? It is going to give us an H plus. Okay, now let's see this reactant first. Now say this is an epoxide, and we know a 3-membered ring is not that stable, right? So now next step is to see whether a 5-membered ring is intramolecular 5-membered ring is possible or not. Now see, count from here 1 2 3 4 5 here. So a 5-membered ring is possible here, and since oxygen has its lone pair, so it is going to attack here and this epoxide ring will break. Okay, and it will give us O minus, and there will be 5-membered ring, right? 1 2 3 4 5. Okay, H is there and there will be positive charge on the oxygen atom, and here the star group. Now it will stabilize the positive charge here, it will become neutral, H plus is going to get removed, and since acid is given, so this negative charge is going to abstract the proton and it will become OH. Now this one is not the final product of this reaction. So since one more intramolecular reaction can be proceeded here, see 5-membered ring, 1 2 3 4 5, right? So again the lone pair on this oxygen atom is now going to attack on the carbonyl carbon, and negative charge will be in the oxygen atom, again it will come back. Now OCH3, that is OMe, it is a good leaving group, it is going to leave and it will give us one more 5-membered ring. Okay, so this will be the final product of this reaction. Now let us see this question. What is the product formed here? In the first step, osmium tetroxide, ether, pyridine at minus 78 degrees Celsius is given. So whenever you see such type of alkenes, there is an also alkene, there is also, but this is an terminal alkene, right? And it is not a, and this is not a terminal alkene. So whenever osmium tetroxide given, okay, and you have a choice between selectivity, then first of all the dihydroxylation means 2OH group is going to get attached here at the terminal alkane, okay, and it will give us this is the product formed in the first step. Now in the second step, so NaIO4 is given in presence of water and tetrahydrofuran. The function of sodium IO4 is that it undergoes an oxidative cleavage. It performs an oxidative cleavage, okay, of the 1,2 diol. So here cleavage is going to occur. First of all, cleavage will occur and it will oxidize this alcohol. So let me write the short way. Alcohol, it is going to oxidize the alcohol, so it is become what? It is going to get aldehyde, form aldehyde. So it will give us and then in the next step Ag2O is given, water and tetrahydrofuran. So the function of Ag2 here is it further oxidizes this aldehyde into carboxylic acid. Hence this will be the final product of this reaction.